Welcome, everyone. Here we go. Save that for the good stuff. It's coming up. Welcome. For those of you that I don't know, my name is Dan Lewin. I'm the CEO of the museum. Been here for about 6.5 years. Particularly excited about this program tonight. It lines up wonderfully with our new mission, which I'll mention in a moment. But I wanted to start off by thanking all the members, the trustees, the supporters, the volunteers, the crew that puts the programs together. We couldn't do it without your support and help. So thanks to everyone. We've got pretty much a full house here today, and we're streaming online, so welcome to the audience who's looking from afar. And you'll know, if you're not aware, that the museum evolved its mission about 6 years ago. We will continue to collect and preserve like all collections institutions do, and we will do it for posterity, but we also care a lot about people. Because in the beginning, people were computers, and then we invented these things called computers. And now life doesn't exist without them. So the mission of the institution has evolved to decode technology, the computing past, where we get agency because we have the collection, the digital present, which is a moving target and it's ever changing, and the future implications on the human condition. And the program tonight is going to speak deeply to that from a personal perspective. And I'm very excited to welcome Fei-Fei Li, Dr. Li, to the program tonight. Her story from this book, The World I See, is really one that speaks very deeply at a personal level, but also at a world-class and definitive professional level about the implications of computing on the human condition. So we do believe that all these technologies can be used for the greater good, and that is our goal at the institution, is to help people realize and consider the best use of these technologies for the greater good. I'd also like to thank tonight's sponsor, the Patrick J. McGovern Foundation. I think we'll put that up on stage. We couldn't do these kinds of programs at scale, and the McGovern Foundation has been a terrific supporter. Pat McGovern, Sr., passed some time ago, was one of the founding trustees of this museum, going way, way back to Boston, where it was initially instanced and obviously moved to the Bay Area some 20 plus years ago. So we want to thank them for their support in an ongoing series about AI and the human condition. So without further ado, you have, I think you're here because you know a lot about, or you're interested in learning more about what's going on with AI and the human condition. And let me introduce Fei-Fei with a little bit of her background. She's the Sequoia Professor of Computer Science at Stanford and the Denning co-director of the Stanford Institute for Human-Centered AI. She was the director of Stanford's AI lab, and during sabbatical was the VP of chief scientist of AI and ML, artificial intelligence machine learning at Google, and did an immense amount of research in that stay as well. She's also serving on the National AI Research Resource Task Force, which was commissioned by Congress and the White House. So please, I'd like to welcome Dr. Li to the stage.
Hi. Thanks, Dana.
Thank you. And Tom Khalil is here to moderate the conversation. I had the good fortune of meeting Tom some long time ago when he was working in the White House, Office Science, Technology, and Policy in the Obama administration. He worked with both the Clinton and the Obama administration, has a lot of experience in the policy arena, as well as working very aggressively in the National Nanotechnology Initiative and the BRAIN Initiative. He's now currently the CEO of Renaissance Philanthropy, which is a new organization focused on the consideration of this new renaissance, which we're living through and in many cases creating in the neighborhood. So I want to thank Tom and Fei-Fei for the program, and join me in welcoming them to the stage. Thank you. Let me leave you with your book.
Okay, everyone has to rush out and buy this book. Get some for your friends and relatives as well. It's a great read. Fei-Fei, we've got to see how nerdy this audience is. So how many of you could explain to someone else how stochastic gradient descent and backpropagation work? Raise your hand. Okay. All right.
Okay, cool.
Fei-Fei, one of the things that you talk about in your book is a little bit about the history of AI. So I'm wondering if you could start with what was going on in 1956 and how long did it take the researchers then to figure that they'd be able to solve artificial intelligence?
Okay. Well, first of all, thank you, Computer History Museum. Thank you, Daniel and Tom, for inviting me. I do want to say that for those of you who are celebrating lunar calendars, happy Mid-Autumn Festival today. Okay, now let's go back to 1956. That's not the Dartmouth workshop, was it?
Yes.
Okay, I thought that was 1959. Okay, so my memory has faded. So there are real historians in this audience, I know that. So 1956, a steamy summer in Dartmouth College. The founding fathers of AI, John McCarthy, Marvin Minsky, Claude Shannon. Who's the fourth person? There's one more person, sorry, we'll remember this. And also convened a group of computer scientists under, I think, a small grant from DARPA, right, to discuss the future, the computing. And that time, I think John McCarthy just newly minted this field, called it artificial intelligence, and they spent the workshop in that summer writing this white paper on what artificial intelligence is, what would it do, how would we solve this problem, focusing really on reasoning, deductive reasoning, and trying to make machines think like humans, answer questions, make decisions. And it's been quite a journey, 70-ish plus years, and we have seen ups and downs. We have seen real, you think we're in a hype cycle now. We had hype cycles in the 70s about expert systems, really starting to see real applications of using first-order logic and expert systems in AI that time. But then that bubble crashed pretty badly because it didn't deliver. At that time, I think there were magazine covers that's talking about robots taking over the society, 1970s. And that didn't deliver. The funding really drained, funding at both in academia as well as in industry drained. I think military funding or defense funding was still there, but some researchers actually shied away from those funding sources. So by and large, the whole field shrunk. And then comes 1990s, I would say, that there is a quiet revolution that started to happen in the field of AI. The whole public world still sees that period as the winter, AI winter, but I personally think that was the early spring where
the green shoots.
Exactly, yeah. The snow hasn't totally melted, mm-hmm. But I think that was driven by first, it really was driven, in my opinion, by statistical modeling, which combined with computer programming, we start calling it machine learning. Mm-hmm. The field of AI and machine learning found its language, and that language, through statistics, through machine learning, start to crack open individual fields like natural language programming, computer vision, speech recognition, and researchers start working these fields in pretty deep ways. Mm-hmm. Personally, I entered AI as a PhD student at Caltech in the year of 2000. Mm-hmm. So a lot of the public still thinks that was the winter time. But for me, two things happened during my PhD. I think that was defining of my generation of AI researchers. One is statistical machine learning. And that's when a lot of, my first class in graduate school, literally the first class I walked into was called neural network and pattern recognition. We read backpropagation papers, but we also did support vector machines, ImageNet, boosting methods and kernel methods and all that. That's one thing that's happening to us. We use these tools to start to look at AI problems like computer vision. But another thing I think that happened outside of our labs, outside of academia, that came to have a defining role in AI is the internet. Because I think Google was founded in 1999 or 2000. The internet started to give us data. And as, just to finish, as you know, and of course there's GPUs starting to come in about 10 years later, so things are start to quietly converge. And I think by around 2010 to 2012, the public moment of AI start to really happen. At least in Silicon Valley, the public moment started to happen when Google and other companies were trying to acquire this little startup that probably doesn't even have a name, coming out of University of Toronto, that won the ImageNet challenge. And then since then, we are in a modern AI, the era of modern AI, rebirth of AI.
Right. So a project that you worked on played a very important role in changing people's views about what was possible. And that was the ImageNet. So you worked with your colleagues to create a data set of 15 million photos and labeled them. So why did that play such an important role in helping to jumpstart this modern wave of AI?
Right, so for those of you who don't know, ImageNet was a dataset project that was started back in 2006 and took a few years and published in 2009. At the end, in 2009, it became the biggest dataset in AI field. It is consisted of 15 million internet images, human sorted, curated, and organized and cataloged across 22,000 natural object categories. And ImageNet project immediately after we published ImageNet as an open source data set, we engaged the research community in this annual ImageNet challenge to ask machine learning researchers and computer vision researchers across the globe to participate in this annual challenge of what we call object recognition. And that annual challenge began in 2010 and led to the moment in 2012, which was the first place winner of that year's challenge is what now everybody knows called AlexNet. Was a work done by University of Toronto researchers, including Jeff Hinton, Ilya Sutskever, Alex Kushevsky, and that moment is pretty symbolic to the world of AI because three fundamental elements of modern AI converge for the first time. And that was namely neural network. This is why Tom was quizzing you on backpropagation. That was the mathematical underlying mathematics of neural network. So first element is neural network. Second element is big data using ImageNet. And the third element is GPU computing. And at that time, it was 2 GPUs. The significance of ImageNet is it's kind of trivial today. Everybody knows AI is driven by data, but pre-ImageNet, people did not believe in data. Everybody was working on completely different paradigms in AI and with tiny bit of data, sometimes not even,
Sort of like handcrafted feature engineering.
Exactly. So this very radical idea is was scratch all that. inundate the models with data, drive high-capacity models with data-driven methods, and to drive generalization in AI. That was deeply suspicious by many people.
Right. And so, there wasn't this view that, hey, one way to think about these neural nets is that they're a universal function approximator, and if you give them enough examples, they can map between the input, they can learn a function that will map between the input and the output. So that wasn't sort of the mainstream view.
No, it wasn't.
Yeah, I see.
Yeah.
Okay. Now, I thought it was interesting in your book that a lot of your more senior colleagues were wondering why you were doing this. I think this is a good example of if you believe in something, sometimes you should keep doing it because obviously it had a huge impact, even if you're not getting the love from your colleagues that you would like at the time.
Yeah, but look, I didn't write it from a negative point of view. I think this is scientific progress.
Yeah.
Is that being challenged, whether it's
Yeah.
your senior colleague, junior colleague, your student, I'm constantly challenged by my students. And I probably have 99 stupid ideas every day, maybe once in a while, one good idea. So it was fine I was challenged. It was fine because it was a untested idea. But I guess the flip side of the story is, for especially the younger people, is just because you're challenged doesn't mean you should give up. So that's the important lesson here.
Yeah. So, now going from 2012 to 2024, what are some of the most important advances that you think we've made in the interim?
In AI, right? Believe it or not, 2012 is also the same year Jennifer Doudna and her colleagues discovered CRISPR.
Oh,
she and I had a conversation that 2012, it turned out, two major scientific technological breakthroughs came in the same year.
Right.
So 2012, since then, it's been 12 years. And what has happened? Well, several things has happened, right? So in the field, in the more research field, I think AlexNet plus ImageNet was a major moment. It really opened the door to the pioneers, including the technology companies like Google started doubling down on deep learning. It was the beginning of deep learning era. Then I think a public moment came in January 2016 when AlphaGo played the Go master Lisa Dole and won the matches. And I think that was the first time that public was aware that machines are powerful enough to challenge humans in tasks that humans tend to think is deeply unique to our ability, right? And also it introduced a new class of algorithm called reinforcement learning, that on top of deep learning. So that was a moment, and then at this point between 2016 to 2022, I think it was a gradual increase of just more investments in AI, in big tech, in entrepreneurship. There is also, it also coincides with the first glimpse of techlash. I would say techlash for a lot of us happened after Cambridge Analytica, 2016 election, but it was around the time machine learning bias was being called out, around the time self-driving car fatality happened. The earliest, I think it's around 2017. So we start to have a societal conversation and tension between excitement of tech, but also concerns of tech. All this, I think, accumulated in end of October 2022, when ChatGPT happened. ChatGPT, for those of us who are researchers, we kind of saw that was happening. You might be thinking, oh, she's just bluffing. But I'll tell you why, because wearing the hat of the co-director of Stanford Human Center Institute, in 2021, we actually founded the world's first Center for Research of Foundation Models because we saw GPT-2 results. And at that time, the public was not aware, but the researchers like us realized, my colleagues, Percy Liang, Chris Manning, they realized, oh my God, this is gonna change. So we immediately put resources to form this center. So when ChatGPT happened, we were kind of grateful we started this, but we also were shocked by the meteoric rise of the attention. I think the difference between AlphaGo moment and ChatGPT moment in terms of public awareness, it's not just the number of people, it's the first time AI is that intimately in the hands of individual users. AlphaGo is not in the hands of any user other than the Go master. But ChatGPT is at your fingertip. And that was an awakening moment not only for every single individual, it's also an awakening moment for governments.
Right.
The kind of, before ChatGPT, our institute had part of our mission is to bridge the gap between tech world and policy world. So you've been in Washington. I would not naturally fly to Washington all the time, but I was going to Washington just to continue the conversation. But after ChatGPT, it was like Washington was just calling us,
Right.
So I think...
Like, what's going on? Yeah.
Exactly. So I think really these 10 years has been, the public sees this in discrete dots of events. Right. We see this as a continuous, just more and more...
Just log plot, right?
Right, exactly. More and more investments and movements.
Yeah. So is there still a debate within the research community about whether these large language models are stochastic parrots or whether they're still, or there's actual reasoning going on? So what do you think of that debate?
I understand why you use the word stochastic parrot, because it's specifically coming from a paper that is critical of large language models. And I think it's important to recognize we do need to criticize these models from different angles, both in terms of its ability, energy consumption, its limitations, bias, and all this. But I wouldn't call, from a scientific point of view, I would use a more neutral tone rather than calling it, either God or parrot. It really is a large model that has so much ability to not only pattern match, pattern learn, but to also do predictions. And also to predictions with very capable demonstration of even some level of reasoning, right? Because it's able to explain to you what things are, right? I know that there's just a new release a few days ago, 01. I personally haven't had time to test it. It took reasoning to even another step further in inference time. So I think it is fair to say it does have the pattern recognition, which some people might call parroting ability, but it also has some level of reasoning. But I'm always so careful, especially being an educator, my responsibility is to be an honest communicator with the public. I'm always so careful from hyping up what this reasoning is, including some more hyperbolic extrapolation of, sentientness or consciousness.
So, what do you think is likely to happen over, say, the next 3 to 5 years? So what do you think are some of the biggest limitations of the systems as they currently exist? And what are some of the areas that you think we can make real progress in terms of improving their performance?
Right, Tom, I don't know if you're asking narrowly about language models or you're asking about AI.
AI in general.
Right.
Yeah, so for example, there's some people who believe that we can just make an incredible amount of progress by buying more GPUs. So buying 2 million GPUs rather than 2 GPUs, and more data, more synthetic data, right? So transformers, attention is all you need. So there are some people who believe that we can just make an incredible amount of improvement by scaling up the technology as it exists today. And there are other people who say, well, today's version of AI has these fundamental limits, and we're going to have to explore new approaches like, neurosymbolic approaches or something like that. So do you have like a strong view on that debate?
Well, so first of all good points. The truth is, I do think we're in a real AI digital revolution. So the next 3 to 5 years will continue to be very exciting for technology, but also tension-filled for our society, including policy. Everything you've asked is more on the technology side. So first of all, I fundamentally believe every point in human history, the technology and science are limited. We can always push the frontier forward. Personally speaking, I'm so super excited by spatial intelligence. That's way beyond language. If you look at human and animal intelligence, language is only one piece of intelligence. Even if we're looking at advanced intelligence, humans have built civilization based on so much that's beyond language, from the construction of the pyramid to the intricate design of machines for the first industrial revolution, the discovery of DNA structures, the creation of cinematography, and all of this, a lot of this is built upon spatial intelligence that goes beyond language. So there are definitely new doors open other than language. Technically speaking, scaling laws for data, we're still seeing a very healthy evidence of scaling law for data, but it's also very intriguing that we're hearing more and more about where are we running into the limit of data, especially text-based data on the internet. It's very likely we're possibly running in the limit. But where I sit in higher education, I also see that there's so many pockets of scientific discovery where data haven't even been properly harvested, from digitization of some of these data to modeling of these data. So I actually think the next 3 to 5 years, we're going to see blossoming of scientific discovery in different fields because of AI, ML, not just the commercialization of large foundation models. We're going to see more spatial intelligence. I'm personally involved in that. I'm excited by that. We are also going to see the next 3 to 5 years is not just the years of technology. It is also the years of how we deploy these models, how we govern these models. Now that, here in our home state, California, there is AI bills being discussed.
Right.
And personally, I'm both supportive of safety measures and policy measures, but also I'm concerned about, even well-intended bills that might have unintended negative consequence to the scientific and open source community. So all this will play out in the next 3 to 5 years for sure.
Yeah, so I definitely want to come back to the policy issues, but I want to maybe have you describe for the audience a little more about what you mean by spatial intelligence. So what does it mean for a computer to be able to see, do, and learn? And how would we know whether we were making progress in spatial intelligence? So, one of your colleagues at Stanford, Chelsea Finn, said, we're still very far away from being able to have a robot show up at a house that it's never seen before and make breakfast, for example.
Very far.
Yeah.
I can't wait, but it's very far. So I was just, this audience is so dark, Tom and I cannot see a show of hands, so I won't ask questions. But if you trace back the development of human language, of course this is still a scientific study area, but roughly the earliest proto-language moment happened in a very early ancestor of humans about 1 to 2 million years ago. That's the earliest you can trace back. A lot of people say languages developed within the language we use today is within the last 300,000 years. But if you trace back the ability to see space, the 3D world, to understand what's going on, to see obstacles, to see food, to see how you navigate, to reason about this, it traces back to 540 million years ago. That's when the animal world underwater first developed light sensors. With that ability, perception began. With that, when perception began, animals start to move in an intensive way. Before that, they're just floating around. They were probably touching a few things because there was early tactile sensors, but it was a very, very chill. But once you can, literally speaking, once you can see.
Did you get that from your kids?
Yes. Well, once you can, well, I work with young students. Once you can see, you start to develop spatial intelligence. You start to plan your life. You start to see food. You start to hide away from being someone else's food. And that evolutionary process of intelligence just began. So spatial intelligence summarizes all this ability. In today's language, I would say, is the ability to understand, reason, generate, and interact with 3D worlds. Now we live in simultaneously physical world as well as digital worlds. So this spatial intelligence applies to both physical and digital worlds. So which ties back to if you ever want a robot that can come to your house to make breakfast, one of the most important things the robot needs to have is spatial intelligence, because the robot needs to know where's your fridge, where's your stove, where's the egg, how do you crack open an egg and put it in a pan, and all this is part of spatial intelligence.
Mm-hmm. Got it.
Why is that so funny?
So there's a lot of discussion about this concept called artificial general intelligence, and I'm wondering whether you think that is a useful concept or not. So what people usually mean by that is that it will be possible to do, maybe let's set aside robots for a while, because that's a little farther off, but that if you imagined a sort of a remote worker, that you would be able to have an AI that does sort of every useful economically useful thing that a human does, we would be able to do with some AGI. First of all, do you think that's a useful concept? Number one, and number two, do you think some people are saying, oh, that's going to happen in 3 years? Do you think that's sort of wildly optimistic?
Right, that's a good question. It's also, I have to admit that it's such a Silicon Valley question. Mm-hmm.
That's where we are, Fei-Fei.
I know. Sometimes in my head, I have dialogues with the pioneers of AI, John McCarthy, mm-hmm. Marvin Minsky, Ramanhart. Also, Alan Turing, he probably would not have called himself the pioneer of AI because mm-hmm. when he was daring humanity with the question of thinking machines, mm-hmm. eventually translated to Turing test, he wasn't thinking about the word AI yet. It wasn't invented. But when I was having dialogue with these giants, I think that their definition of AI would be very similar, is that general capability of intelligence. Mm-hmm. So if they called AI having that in mind, it is hard for me as a scholar to differentiate the word AI from AGI, mm-hmm. because I think they're deeply overlapping. Right. And if you look at when AGI as a term came about, it was probably not even 10 years ago, it came out of more the industry marketing world. There's nothing bad about it, but from an academic, scientific, technological researcher, educator point of view, some of you who read my book knows I use this word North Star a lot. As a scientist, we chase those hardest problems that we might never solve in our lifetime, but they inspire us. And I think the North Star of AI as a field is always that general capability. So what do I think about the word AGI? Nobody asked me when they invented that word. It's fine, but the AI that as a field that we love, we still believe in, is largely overlapping with this definition. Now, 3 years, are we going to achieve that? If I'm in front of a venture capitalist, I'll say yes, of course. But you're not, and you're not. So I think we need to be responsible. You know, what does that mean? Would machine surpass human in important tasks? We have already done some of that.
Right.
You know, like the DARPA Grand Challenge of self-driving car was 2006, right? 2006, my colleague Sebastian Thrun and his team let a car drive 138 miles in the desert of Nevada, right? And that was an incredible capability. And then we have machines that can translate tens of languages. That's just superhuman. We have so many tasks that already surpassed.
AlphaFold.
AlphaFold, AlphaGo. You know, even ImageNet. That's 1,000 arcane classes of objects like star-nosed mole, or so many species of dogs, and these are all superhuman capabilities. So I think we have achieved some. We'll continue to achieve some, but that I think without a clear definition, if the holisticness of being human and being as intelligent as human, as being as intricately and complex as human in 3 years, I do not believe.
Okay. So let's talk a little bit about what you're doing at Stanford with this initiative on human-centered AI. First of all, what do you mean by human-centered AI?
Yeah, that's a great question. I think human-centered AI at this point for me is a framework to think about yours AI work. Because AI is made by people, is used by people, will impact people's lives, and what is a guiding framework to think about this technology? I came out, I think in March 2018, I was still a chief scientist at Google. I wrote a New York Times article putting a stick on the ground and calling this framework human-centered AI, precisely because I was so inspired by my work at Google. I had the chance to interface with so many businesses, from individual developers in Japan, cucumber farmers using AI, all the way to Fortune 50 companies hoping to use AI to revolutionize their entire business model. I realized this technology is bigger than anything I had imagined. It's going to impact our lives and businesses and the world in such a profound way. And that realization actually sent a chill down my spine. It is scary to think that way. It is scary to realize a tool can be that powerful. And we better think about the implication. And to me, that deep implication has to be grounded in the human implication. And once I thought about that, my colleagues and I at Stanford put that stick on the ground and say, we need to approach AI with a human-centered framework. Now at Stanford HAI, we think about the human impact of AI in 3 concentric rings: individual, community and society. I'll give you an example. Individual really has to do with every single individual matters. How does this technology impact you or benefit you? If you're an artist, how are you using that to augment it? Or is it taking away your intellectual property? If you're a patient, is this technology making you heal better without taking away your human dignity? If you're a student, how are you learning anything you're interested through the help of this technology? So there's individual impact. Then there's community impact, right? How can AI be used as a tool to help communities that are under-resourced? For example, AI plus telemedicine is a deeply, deeply good use case for communities that don't have access to hospitals and enough doctors. In the meantime, can biasing AI impact one community more than the other? We're seeing that already. So that's the community aspect. Then we have society, right? Today we cannot stop talking about AI's impact in November. Our democratic process, how is AI and deepfake and information war going to change all this? We cannot stop talking about jobs. From software engineering to truck drivers to radiologists. In fact, AI is impacting the whole society. So all these are human issues. So math is clean, but human world is messy. And AI has exited from owning that clean math, clean programming world to the messy human world.
Yeah, somebody once said, technology is easy, humans are hard.
Yes, especially little ones.
Yeah. What are some of the potential benefits and applications of AI, like ambient health, that you're most excited about?
Right, thank you for cueing that, because it's chapter 10 of my book. But there really it is, boundless. Personally, I got very inspired by just spending endless hours sitting in primary care, emergency department, outside of surgery rooms, in ambulatory care settings, because I have an ailing parent who is deeply, deeply ill for so many decades. I take care of my mom, and I realized our healthcare system is full of humans taking care of humans. But all these humans, healthcare workers, from nurses to doctors to caretakers, they don't have enough time and they don't have enough help. So ambient intelligence in healthcare setting really came from a collaboration between me and my collaborators in Stanford Medical School, wanting to use technology to provide an extra pair of eyes and ears to help doctors and nurses and caretakers to make sure our patients are safe or their situation is not deteriorating rapidly. For example, I don't even want to see a show of hand, it will just make me sad, but so many of you have personal family members and friends who have fell. And that's a deeply, deeply painful and costly injury, especially for elderlies. But how do you predict that? How do you alert that? How do you help them? How do you help our elders or patients? It's hard to have a human to be watching 24 hours, but computers and cameras can help. Ambient intelligence can help monitor the COPD patient in terms of the way their conditions are and alert doctors when the oxygen has changed rapidly or some situation has changed. So that's just one example of AI being almost a guardian angel to be augmenting our caretakers to take care of people. But we're seeing exciting use cases in education, personalized learning, right? It's so obvious that AI can can be a tutor, can be a TA, can be a teacher, assistant to our teachers in different learning environments.
I think one of your former graduate students, Andre, is working on that.
Yes, exactly. Yeah, I just saw him a few days ago.
Yeah.
Yes. But there are a lot of use cases in agriculture, believe it or not. I had a former student years ago, before deep learning revolution, started or co-founded a startup using computer vision technology to detect weeds in fields so that it can, it can keep the crops healthier. I've heard salmon farmers using AI to help farming salmons. The use cases of positive uses of AI is just countless.
Right. And so how can we prepare more people to have both a computational background but also be a domain expert? For example, in the same way that your colleague Daphne Kohler has a machine learning background, but she's also learned a lot about healthcare and drug discovery. Because it seems to me that the people who have a foot in both worlds of both the computational expertise and domain expertise are going to be in a position to help identify some more of these compelling use cases.
That's a great point, Tom. I deeply, deeply believe in interdisciplinary and multidisciplinary approach. Even if you don't want to get a PhD at the intersection of, I personally got it at the intersection of AI and computational neuroscience, or intersection of AI and computational biology, or intersection of AI and political science. Even if you don't go as deep as a PhD, in all your journey as a student, there is a lot of value to embrace both the computing, the STEM fields, as well as your areas of passion, whether it's biology or art or policy or chemistry and so on. So for students out there, if you're in school, if you're thinking about college, if you're in college, I do think what Tom said is really valuable, is to embrace that interdisciplinarity. I think zooming out a little bit, AI is the new language for computing. I have been quoted in saying that anywhere there's a chip, there is or will be AI. As small as a light bulb, which has a chip in it, there will be AI. As big as robots and cars and whatever. So given how important this technology is, I do believe in educating our kids young, educating our students from all background, all walks of life, educate our public with this technology. At least if not coding, at least know what this is. But last but not the least, I also think even if your passion is not in computer programming, or in the technical details of AI, if your passion is in arts, if your passion is in political science, in law, in medicine, there is a place for you because it's the domain experts who will be using AI to make a difference in your domain. So don't be afraid of embracing it from your perspective and use it to make a positive difference.
Yeah. So which of the, there's, people list a lot of potential risks. So you've already talked about some of them. People are going to lose their jobs. People will use deep fakes to disrupt elections. We'll be reinforcing existing biases. Some people have more speculative concerns, like this idea of instrumental convergence. So if we give an AI system an objective function of trying to achieve some goal, then it's going to have as sub-goals wanting to make copies of itself and have access to more computational power. Which of the risks that people talk about do you take the most seriously?
Yeah, look, there are many risks. Every technology, every powerful technology has created harm, has been used for harm, And even well-intended has had unintended consequences, and we have to face that. But if you are forcing me to pick a risk, as an educator, I would say the biggest risk of embracing the new era of AI is ignorance. Is not just the basic ignorance of, I don't know how to spell the word AI. It's not. It's even some deeply learned, knowledgeable people, when they are ignoring details, nuances, and are communicating AI in hyperbolic ways, that is a risk to the society. But ignorance, we know if we're too ignorant of this technology, we miss the opportunity of using it to our benefit. If we're ignorant of this technology, we cannot call out or recognize the actual risks. If we are spreading the ignorant message, we also are misleading the public or policy making. So a lot of the root of these issues are actually stemmed in the lack of understanding, so that we're not assessing risks right, or we're hyperbolically communicating it, or we just completely just missed it. So that's how I would put it.
And what are some examples of that you see now, where people are saying things that you think are totally off base?
Well, okay, so I think anybody who says AI is all good, as if, you can swap in this word, technology is all good, it's only good, it can never do bad. I think that's an ignorance of the past, right? We look at humans' history with tools. Every tool has been used in harmful ways. So we have to recognize if your data set is biased, you're going to have really bad downstream impact in terms of fairness. If you are making, if you don't know how the AI is made, you might actually be so ignorant and be working with deep fakes without your knowledge. So these are all not good. But there is also another swing, which is this is such a demon that it's existential crisis. It is gonna proliferate itself, replicates itself, turn off, I don't know, power grids and all that. Also, I think that is hyperbolic, and it ignores that AI is not an abstract concept. It actually lives in physical systems. Even if it's virtual software, digital programs, it lives in physical systems. It lives in data centers. It lives in electric grids. It lives in a human society. And there are so many things that is tethered and contextualized that it's, that hyperbolic assumption is
but, some of the
wrong.
people raising some of these more speculative concerns are people like Jeffrey Hinton, who, presumably understand the technology. So why do you think that there are, why do you think that there are people who've been deeply involved in the technology who've gotten more concerned over the last couple of years?
Right. So first, Jeff, I really, really respect Jeff. I knew Jeff since I was a graduate student. Actually, last year, I was in Toronto. I had a public discussion with Jeff Hinton on this very issue, and it's on YouTube. I think it's one of the very few times that Jeff and I, or Jeff and anybody, had a public discourse about this. If you listen to him carefully, he is concerned. He's also calling out the potential risks.
Right.
But, there is also a layer of amplification of his concern. And we have to dissociate. I totally respect that discussion with Jeff. And I agree with him. Irresponsible use of this technology would lead to really dire consequences. He has his version of irresponsible use. I have my own version of irresponsible use.
Yeah.
I think also, I respect every individual for calling out these risks in their own ways. But I also want to be a responsible communicator and educator. I want to let the public know that it is still our human, collective, individual responsibility to harness and govern this technology. And there is absolutely, it's not only there's time, it's absolutely there's time. There's also, there's just everything it's in our hands, and we shouldn't give that up.
Right. So you talked about governance. And you've played a very important role in getting this idea of a national research cloud on the political agenda. If you did have an opportunity to brief the next president and they said, Fei-Fei, what should I do? What advice would you give the next president about the most important things that the US government could do to try to promote the benefits, but also understand and manage the risks?
Right. I probably will say the same thing as I said to President Biden last June, and also earlier this year, I met him at the State of the Union speech, is that I believe that our nation needs a very healthy AI ecosystem. And when I say it's an ecosystem, it includes public sector, academia, entrepreneurship, we now call little techs, as well as big tech technology. And our country is a very strong democracy, and we believe in the value of this democracy, and I believe that having a healthy AI ecosystem plays to our strength, and it can have a very positive role.
But what's something we could do to try to...
Public investment.
Yeah,
public investment is really, really important. Now that I am partially in the private sector, it makes me even more convinced that the discrepancy between private sector investment and public sector investment of AI is just so huge, right? Like my Stanford Computer Vision Lab, shared with a couple of other faculty, has 0 H100. It also has 0 A100. We're still using A6000 and other older chips, and yet the big tech has, like you said, hundreds of thousands and millions of chips. And I think that public sector investment is where the gardens of ideas, the flowers blossom. Right. We wouldn't be here today, and I wouldn't be here if it were not to public sector. Right. And also,
I mean, when did Geoffrey Hinton start working on artificial neural nets? How many decades ago?
Yeah, well, he was in CMU, or maybe even earlier, right? ImageNet was from public sector, and the next 3 to 5 years, we talk about the scientific discovery. We're going to see exciting things coming out. A lot of them will come out of public sector. And also, the best thing that come out of public sector, academia, guess what? Are
students.
People. Exactly. So we need to invest public sector.
Yeah, great. Well, we have a very smart audience, so I'm sure you've come up with lots of really good questions. Let's see. One was, for your new company, how will you collect enough data to build a spatial map of the world to support real-time localization? So you might want to address the premise of that question, but clearly, data is going to be, you're not going to be able to make progress on spatial intelligence in the absence of data. So maybe you could address that.
Right. We are not publicly discussing the details yet because we're not ready. When we're ready, we will. I'm a little amused that this person already knows what we're building. That's their version of story. I'm not commenting on that, but you're right. AI is driven by data. It's important. Our company's spatial intelligence is absolutely pixel-based, right? So a lot of pixel data will be driving this technology.
Right. Here's a great question from Amy, and this relates to something that you worked on, AI for All, but she says, I'm a 12-year-old middle school student. What can we do to encourage more girls to study AI and better prepare for the AI era?
Great question. I think every 12-year-old should be encouraged to embrace this. No matter if you're a girl, a boy, you live in rural world, you live in Silicon Valley, this is, if you love it, embrace it. And for Amy, as well as just thinking about when I was 12-year-old, there was no AI. Well, at least I didn't know there was AI. I loved math, I loved physics. The one thing that I'm grateful today that my parents and my teachers did to me, and I will say it to Amy and all the students out there, is follow your passion, follow your curiosity, and be resilient. Do not, if there are negative voices, just tune it out. There are plenty of people, from your parents to your teachers to your friends to your role models, are out there to support you. And just keep doing it, keep going.
What's the most important human problem to solve with spatial intelligence beyond making breakfast?
Lunch? No, just kidding. Spatial intelligence really can power many things, from creating to design. How many of you want to just have an app that you can just imagine all the furniture, rearrangement, to robotics, to AR, VR, to, the specific areas, whether it's teaching, learning, healthcare, factory, manufacturing, and all that. So it really is a deeply prevalent horizontal technology that can impact all of these areas.
So we have a question about the combination of small models and AR glasses. So is that something that you've thought about?
I'm definitely excited by the new media. I know this is early, right? Like, again, we're in Silicon Valley. I'm sure many of you have stayed up late to buy the Vision Pro. So I was very excited, actually. Apple called it spatial computing, because at that time I was already thinking about spatial intelligence for many years. And I was like, yes, because spatial computing needs spatial intelligence. So, but just this form factor of glasses, or I really believe in glass, possibly headsets, but glass are very exciting to me. And the edge compute or small models is very exciting. But small models can be useful not just for glasses and headsets. It really is very powerful for edge compute, whether it's smart devices, robots, especially home robots. You cannot carry a server in the back trunk, right? So there's a lot of use for small models.
Yeah, I'm very interested in the role that multimodal models and smart glasses could play in terms of workforce development.
Yes.
So there are a lot of, we don't have enough electricians. So you could imagine that sort of earbuds, AI, and smart glasses
Absolutely.
providing sort of just in time, just enough training as part of an apprenticeship program.
Yep.
What can we do? What can the research community do? What can companies do to address the fact that other languages other than English are underrepresented?
Right, so this is a great question. This goes to data bias and all this. First of all, I do think when I say public sector investment in AI, I think every country should have public sector investment in AI. That itself is related to the local culture, local language, So from that point of view, it is individual researchers. It's important individual researchers pay attention, but it's also important that governments and big organizations that can deploy large amount of resources pay attention to this. It's absolutely true that English is dominating. we should be aware of that. And this goes back to my point of public sector investment, even in this country, right, is that I'm sure we have incredible researchers, students out there thinking about other languages, but right now they're lacking data sets, they're lacking compute resources, and we need to fix that.
So there were some kind of philosophical questions from the audience. And I'm wondering, if you can talk about what sort of effort you've made to engage people in the humanities and the social sciences at Stanford, and what are some examples of insights that they've been able to provide that have been sort of interesting to you as a computer scientist?
Actually, this is the most fun part of my last 5 years establishing and co-running this institute, is really reaching across the campus. Stanford particularly has about, I think, 8 schools, from school of the law school, the business school, the medical school, now the sustainability school, the humanities and natural sciences school, the engineering school, just talking to colleagues and reaching out to students and researchers and scholars across the campus is extremely fun and illuminating. What have I learned? For example, talking to my humanities colleagues really opened up my understanding of human expression and creativity. And what does it mean? How do we think about AI's relationship with people who are deeply creators? Especially when ChatGPT and Sora came out, from Hollywood's writer's strike, all the way to the concern about the voices, the artists, the individual copyrights, all the way to artists who are at the avant-garde of embracing this tool. It's just so complex. It really, I didn't have a formal education to even wrap this around my head, and they teach me in thinking about that. One thing I did learn, again, talking to this audience, probably deeply technical, I think it's really important technologists listen and reach out to humanists and social scientists. And also in your own work setting, it could be, legal, it could be, product, it could be marketing, it could be many different functions. Because technology doesn't live in a vacuum. It takes a complex human effort to make technology benevolent and good. And just going in with that humility and respect and giving the other side the dignity they deserve is really the most fundamental thing we could do to form these bridges.
How important is it that you think we make progress in areas like explainable and interpretable AI?
That's a great question. I think by and large it is important, but again, I think it's important we go a little nuanced. For example, even explainability has different layers. For example, everybody knows Tylenol is good for fever and headache. Explain to me the molecular pathway of Tylenol. In fact, even today, even scientists don't know all the details. Yet, you will never say Tylenol is an inexplainable drug. It's because there is a whole system around drug development, around regulatory measures, around the approval process of a drug that has enough of the explanation that made you or most of the public convinced and feel trusting. So that's one way of explainability. Another way of explainability is, for example, especially you, Tom, drove from Lafayette over here. Mm-hmm. Google, if you put in Google Map, it will give you choices.
Right.
This route you pay, but it's 4 minutes faster. This route is scenic, I don't know if there's any cynic route from Lafayette to Mountain View right now. But honestly, that doesn't explain to you the algorithm of point A to point B. But as a human user, you feel there is enough explainability in terms of your choices. And again, back to medicine, we hardly any of us who are not doctors understand treatment, yet your doctor used certain kind of human language to explain to you what this treatment is. I'm using this example, I'm spending time to use this example to kind of share with you that it's important to think about the use case. It's also important to think about the definition of explainability. And that definition, the particular definition and particular use case really need to match. Sometimes we don't need the mechanistic molecular pathway level explainability. Sometimes we need a different explainability. And so to answer your question, it is important, but it depends on the use case. It's important in different ways.
Well, we have a lot of people in the audience who would like to know more details about your business plan for World Labs, but we'll skip those questions. So
they're the VCs in the audience.
Yeah. So there's a question, you mentioned that in addition to studying AI, you also studied neuroscience. And so there have been some people who are interested in the question, what can AI learn from neuroscience? So the convolutional neural networks were at least sort of loosely inspired by how the human visual system works. Yeah. People have looked at the dopamine reward circuit, and that's been a source of inspiration for reinforcement learning.
Right.
Are there other areas where you see potential collaboration between neuroscience and AI? Clearly, Mother Nature has figured out something about low power computing because
exactly.
our brain only uses 20 watts.
Right, exactly. So, dimmer than any light bulb in this room. So, when we founded Stanford HAI, one of the three major research pillars is neuroscience, the cross-disciplinary collaboration between neuroscience and AI, to me, is foundational to the advance of our field and also to the advance of both fields going forward. And I'm very, very lucky to work with colleagues like Surya Ganguly and Mike Frank and Noah Goodman. A lot of colleagues at Stanford are at the forefront of this interdisciplinary research, right? For example, young children's development, early days, kids, very young children do a lot of curiosity-driven learning. How does that translate to AI, AI systems?
Right.
That's one inspiration. Right. We also know that backprop is a very, very simplistic translation of what's going on between the two neurons in our brain. In addition to synaptic connections, there's a lot of dendritic connections that are actually deeply electrical, chemical, and very nuanced. No machine learning algorithm today has incorporated any of these complicated, new, interesting synaptic and neuronal communication channels. And the flip side is totally true. Our neuroscientist colleagues, whether they're using animal models or cellular models, are collecting a massive amount of data. And using machine learning or AI is a fascinating way of helping them to discover their science. And last but not least, even my lab, I find it fascinating that now we're collaborating with psychologists and using non-invasive electrical EEG waves from humans to drive robots, that's completely in non-invasive ways. So the point is, these two fields have a lot of cross-pollination, and to me, it's one of the most exciting area of interdisciplinary research.
Right. Right. Well, Fei-Fei, we have enough questions to keep you here until 10. But please join me in thanking Fei-Fei for a terrific interview.
Thank you.
And remember, the world's I see.
Yeah, that's for sure. So thank you both very, very much. Again, this is a terrific, there's so many takeaways that I have personally. The public support is really one that's so fundamental, I think. And Tom, you had a lot to do with some of those things in government. And I think without it, we're going to be at a loss, at this stage, because so much of this is tied to the societal implications. The person that you were looking for, the fourth person at the Dartmouth conference, was Nathaniel Rochester, who was working at IBM at the time. And I wanted to tell all of you who haven't been in the exhibits lately, there's a Hollerith machine downstairs, which is a machine that Herman Hollerith built as a result of a public call to solve a problem that the US government had, which was to codify the census from the 1890 era, because the techniques by which the addition was done would not allow for the census to be counted in due time as a result of the population growth. And through the combination of public call and private initiatives, he came up with a machine that was based upon a punch card, which was designed and built for the jacquard looms in the Industrial Revolution to store the patterns by which all these fabrics and drapes were considered. So we just go back to whether it's DARPA funding or whatever, there needs to be a societal call for this, and if not now, I don't know when. So you laid out some wonderful thoughts for everyone on stage. I'd like to thank you both again, and please join me one more time, and then don't go away. Thank you. You have to go.